from Adjacency Matrix to Branch Assignment Table. First, another example based on the last video. Here is a circuit. And here are the nodes and then the branch assignments. For example, branch 1 goes from A to B, branch 2 from A to D, and etc. And so you can see the calculations on the right and the adjacency matrix on the left of the branch assignments that were entered. Now our goal is to go from the adjacency matrix to the branch assignment table. If we start with the adjacency matrix, notice that there'll always be zeros where row and column match because we don't have any short circuits. And also, the lower left half of this matches the upper right half because of symmetry. So really, where the column is greater than the row, in other words, B, C, D when I'm on row A, C and D when I'm on row B, where the column is greater than the row, that's where the unique values are. So from this adjacency matrix, just looking at the unique elements, we want to calculate and populate the branch assignment table. So in this layout, I have a calculation area, and again, the goal is to go from the adjacency matrix to the branch assignment table. First, let's look at how to index those unique elements in the adjacency matrix. I have a node count and the combination of that taken 2 at a time calculated. Then I have, from some index numbers, I have what essentially will give me blocks of 4, which is coming from the node count. And they'll essentially be rows and columns indexing the adjacency matrix. So the quotient is like integer math, dividing by the index number by 4, and mod is like the remainder function after dividing by 4. But I've had to subtract 1, then do the function, then add 1 to get the cycle to be what I want, going from row 1, column 1 through row 1, column 4, and etc., row 2, row 3. Now I've added a lookup table that relates the node number to a prime number. And what I really want to do is keep column numbers from the mod calculation if they exceed the row number coming from the quotient calculation. Also being careful that the row number does not exceed the node count. Then for a value, I basically take the product of primes looked up in this table to give me a unique value for that particular pair of nodes. And now finally, I just basically sort columns Hij, but using the small function. What I call sort is basically the smallest, using the index number, the smallest first element in the value column, smallest second element, third element, etc., being careful to not count zeros. And then RF and CREF are looked up from the sort number to give me the row and column numbers that I'm keeping. I also have this reference, which is just which we'll see later. R number, C number is used as an indirect reference later. I have these little offset values because the adjacency matrix, based on where it lives in a worksheet, it doesn't start off at row 1, column 1 in the worksheet. So I'll need that to adjust. So to continue, let's go back to the previous layout. And this B options will be the list of those sort numbers I calculated earlier. And then I'll now use that indirect reference. But notice that the adjacency matrix starts in J3. So to get that to start at 1, 1, I have to put these offsets in here. And now I'll use the indirect reference. So the indirect function and the reference I formed, and the false keywords to use RC style instead of the A1 style. And so let's just paste this down and see what we have. I want to preserve the formatting. And there, and then let me also sum up this column, and then we'll review what's happened here. Okay, so what's happened is the B options represent unique pairs of nodes in the adjacency matrix. And with the indirect function, I looked up the number of connections. For example, if you look at the adjacency matrix, row A, column B, that would have the value 6. And I get under column W 1, and that's the value there, right? So the indirect function is looking up those unique values in the adjacency matrix and just placing them in a column. Next, I'll take those branch counts that I got from the adjacency matrix, and I'll keep subtracting 1 until I reach 0. This calculation table might need to be larger if there's more than 6 branches. Just paste that through. And there. So now I've taken those branch counts and kept decreasing by 1. And now below, or wherever you want to put it, I'm basically going to look at the above table, calculation table, and if I have something greater than 0, I'll make note of that B option number, which is that unique prime product. And there. And so now wherever I have a branch, it's identified by that prime product number. So let's get those listed under B prime. Again, we'll use the small function and just find the smallest first, second, third, fourth, fifth, sixth element in that block of numbers, being careful not to count zeros. And here is the function that accomplishes it. Basically, it's the small function, not counting the zeros. And we'll just paste that down, and that will be our list of branches in the form of a product of prime numbers. And to finish this off, if I take that B prime number and divide by the node prime and get another node prime, then this countif function will give me a 1, otherwise a 0. And so if we paste this through, and there we are, and that's our branch assignment table. So again, if you look at, say, the first element for branch 1, node A, and I have a 1, right? That's because 6 divided by 2 exists in the list. It's number 3, right? But if you look at, say, branch number 2, column B, 14 divided by 3 is not in the list of nodes, so that was a 0. So that's how that prime and countif function worked. And there you have it. We have the branch assignment table from the adjacency matrix.